When did El Niño begin? That question might sound straightforward, but like a certain boy who never grew up, El Niño's origins are murky and hard to pin down. For centuries, fishermen reaped a bounty off the Pacific coast of South America, where north and west flowing currents pulled cool, nutrient-rich water from the deep. But every so often, the currents would stop or turn around. Warm water from the tropics would drive the fish away and leave the nets empty. These periodic warm spells were most noticeable around December or January, around the time of Christmas and the birth of the boy child. But some of the first scientific descriptions of El Niño came during exchanges between the Lima Geographical Society and the International Geographic Congress in the 1890s. But the roots of El Niño stretch far back into history. Long before the birth of Jesus of Nazareth or the arrival of Peruvian fishermen, the chemical signatures of warmer seas and increased rainfall have been detected in coral samples and in other paleoclimate indicators since the last ice age. This pattern of water and wind changes has been going on for tens of thousands of years. Earth scientists, historians, and archaeologists have theorized that El Niño played a role in the demise or disruption of several ancient civilizations including the Mocha, the Inca, and other cultures in the Americas. But the recorded history of El Niño really starts in the 1500s, when European cultures reached the New World and met indigenous American cultures. Here are some highlights from El Niño's long history. 16th century historical research has suggested that the Spanish conquest of the Incas in Peru may have been aided by El Niño conditions. When Francisco Pizarro first sailed from Panama along the west coast of South America in 1524, his progress was slowed and ultimately stopped by persistent south and southeasterly winds which follow the pattern of the north-flowing coastal currents. In 1525-26, however, Pizarro got much farther down the coast, riding on favorable northeasterlies according to geographer Cesar Caviedes, author of El Niño in History. When Pizarro returned in 1531-32, his ships made haste down the coast, pushed along again by strong northeasterlies, the kind that blow in El Niño years. Once Spanish troops moved inland, the humid air and moist land, 18th century, between 1789 and 1792. The monsoon in South Asia failed multiple times according to historical and scientific records. There is evidence that several other climate patterns, some of them affected by or coinciding with Asian monsoon patterns and El Niño-influenced storm tracks and westerly winds near Europe. According to some researchers, the combination of climate anomalies and unusual weather led to crop failures in Europe and set the stage for some of the unrest that exploded in the French Revolution of 1789. 19th century, in the book Late Victorian Holocausts, historian Mike Davis suggests that at least 3 great famines in the late 19th century were connected to El Niño: extreme weather and the collapse of monsoon. Circulation patterns documented by British and Indian officials, among others, led to great droughts and a few floods in 1876-78, 1896-97, and 1899-1900. Between 30 and 60 million people perished in India, China, and Brazil, among other countries. Hundreds of millions suffered through hunger and social and political strife. Though European colonialism and the spread of laissez-faire capitalism played important roles in these calamities, the global reach, teleconnections of El Niño and La Niña likely spurred the great droughts, crop failures, and malaria outbreaks. 20th century, in the 1920s, a transplanted statistician and physicist from Britain began to piece together the big picture of this global weathermaker. While working as director of observatories in India and studying the monsoon, Gilbert Walker noted that when pressure is high in the Pacific Ocean, it tends to be low in the Indian Ocean from Africa to Australia. These conditions are associated with low temperatures in both these areas, and rainfall varies in the opposite direction to pressure. He dubbed the alternating atmospheric weather pattern the Southern Oscillation, noting how highs over the tropical Pacific coincided with lows over the Indian Ocean, and vice versa. It would be another 4 decades before Jacob Bjerkenza, Norwegian-born scientist who helped found the meteorology department at the University of California, Los Angeles, made the final connection between the alternating warm and cool patterns in Pacific waters and the atmospheric circulation described by Walker. The entire pattern came to be known as ENSO, or El Niño's Southern Oscillation, and it includes the sister phenomenon known as La Niña. At least 27 El Niños were recorded in the 20th century, and each brought its own wrinkles that piqued the interest of scientists and sent ripples through economies. The El Niño of 1957-58, for instance, caused serious damage to the kelp forests off California. Another event, in 1965-66, crashed the market for guano fertilizer in Peru and also spurred the use of soybeans for animal feed. In 1972-73, the anchovy population crashed, leading to the deaths of millions of seabirds and destabilizing effects on the Peruvian economy and government. In 1982-83, the first major El Niño to get significant real-time study, seabirds on Christmas Island abandoned their young and flew out over the Pacific in a desperate search for food. Nearly 25% of the fur seal and sea lion populations off Peru starved to death. To ask why El Niño occurs is like asking why a bell rings or a pendulum swings. Atmospheric scientist George Philander wrote in a 1999 paper, "It is a natural mode of oscillation. A bell, of course, needs to be struck in order to ring." After nearly 100 years of investigation, scientists are still not sure what rings the bell. They just know that it rings. Scientists now know that El Niño is driven by the complex interaction of ocean currents, wind patterns, and atmospheric gases. At its core, El Niño is characterized by unusually warm surface water in the eastern Pacific Ocean. Typically, trade winds blow from east to west along the equator. This pushes warm water towards Asia and Australia. But when El Niño conditions occur, those winds weaken or even reverse. And instead of piling up in the western Pacific, warm water sloshes eastward toward the Americas. While this process is happening, less warm water is upwelling off the coast of South America, so the fish go elsewhere, too. One of the hallmarks of El Niño is the disappearance of the upwelling, says climatologist William Patzert of the Jet Propulsion Laboratory in Pasadena, California. The whole marine ecosystem shuts down off Peru and Ecuador, and while scientists have finally figured out what's causing El Niño, they can't predict exactly when it will happen or how strong each event will be. Even though we've been observing El Niño events for centuries, it's one of the biggest problems facing mankind today. El Niño is notoriously difficult to forecast. Because of the chaotic nature of our planet's climate system, chaotic systems are highly sensitive to their initial conditions. Small changes in starting conditions can lead to dramatically different outcomes, which is why small errors in measurements grow exponentially and make long-range forecasts unreliable. For example, in July of 2014, scientists declared that the Pacific had entered an El Niño southern oscillation event, but after a year of monitoring, it became clear that the event wasn't very strong. By late 2015, though ocean temperatures had risen significantly, but El Niño isn't always a harbinger of big news. While meteorologists keep a close eye on ENSO conditions, an event has to meet a few criteria to be considered an El Niño. In early 2018, researchers announced that El Niño conditions had developed in the Pacific. It's not likely to be very strong, though, and it's expected to weaken later in the year. But if it does strengthen, it could mean drier conditions in the southwestern United States, wetter than average conditions in the northern tier of the states, and an active hurricane season in the Atlantic Basin. That's a lot of potential impact from a phenomenon that's really hard to predict. So, when will El Niño strike again, and what will it bring? Scientists can't say yet, but they are watching closely because no matter the strength of the next El Niño event, it will bring changes to weather patterns around the globe. Thanks for watching.